Hello students, welcome to your video lesson on surface area. We're going to basically be looking in chapter 8 at three-dimensional figures, which are called solids, three-dimensional solids. We're moving from 2 dimensions into 3 dimensions, okay? And in this chapter, we're going to talk about prisms, cylinders, pyramids, cones, and spheres. And I have examples of each of those for you here. Now, these 5 shapes correspond to the 5 sections in chapter 8. The first one is about prisms, which we see here. Specifically, this is called a rectangular prism. There are also things called triangular prisms, or you can make a prism really out of any shape. So, you can have a triangular prism that has a triangle, and then you drop things down, and then you make the triangle on the bottom, and then, you can make a triangular prism like this, where the top and bottom are triangles. In this case, this prism, the top and bottom are rectangles, okay? So that's what we're going to focus on in terms of our surface area, but you could, in theory, find the surface area of other prisms as well, just with a slightly altered formula. We're going to look at cylinders, which is, a circle on the bottom, circle on the top, and then, basically a stretch between the two, like a soup can. We're going to look at pyramids, specifically rectangular pyramids where the bottom is a rectangle. You could also have a triangular pyramid, where the bottom is a triangle, and then you have three sides coming up, something like that. Triangular pyramid, we're not going to look at the surface area of those. You could have a lot of other types of pyramids as well. We're going to look at cones, which is like a pyramid, except the base is a circle. Then obviously if you flipped it over, you could fill it with ice cream. And then we're also going to look at spheres, okay, like three-dimensional circles, balls, ball-shaped three-dimensional figures, okay? So finding the surface area of a three-dimensional figure basically involves adding together all the faces, figuring out how much material would I need to cover over this thing, right? Basically wrapping a present. How much wrapping paper am I going to need to wrap this present up perfectly tight, okay? So we're going to look at formulas for each of these different types of figures: rectangular prisms, cylinders, pyramids, cones, and spheres. And we'll start with rectangular prisms. These are probably one of the more basic types of shapes, but it has not necessarily the most basic formula, okay? So in this particular case with this shape, finding the surface area is really just adding up the area of 6 rectangles, okay? And we talked back in chapter 5 about finding the area of rectangles, just multiplying the length and the width or the base and the height, right? So we're basically doing that same thing in this case when we're finding the surface area of a rectangular prism, but we have a shortened version of the formula to help us out. So there are 3 dimensions. Obviously, in this case, it is a 3-dimensional figure. So we have the length, we have the width, and we have the height. Okay, and these are sort of interchangeable. It doesn't matter which one you call the length, which one you call the width, which one you call the height. But in this case, length, width, and height. And the bottom of this rectangular prism down here is a rectangle with an area that is the length times the width, right? And then I have the top of the box, which is exactly the same thing. So that's why here I have 2 times length times width. 2 length times width. Length times width gets doubled because it's a top and a bottom, okay? Then we also have like this front side, okay? Like the front side of this box here is a rectangle with length and height, right? Length and height. And then on the back side, there's the same thing, right? Back on the back side, there's the same thing. So that's why I have 2 length times height right here. 2 rectangles whose dimensions are the length and the height. And then finally, I have the left and the right-hand sides of the, whoops, where did they go? Whoop, bring it back, okay. That's the button I want. Right, so I have 2 width times height, and those are the left-hand side and the right-hand side, okay? So those 2 rectangles are the width times the height in terms of their area. So we have 2 of those, and we add up these 6 rectangles, right? 2 of these, 2 of these, 2 of these, and that's the surface area all the way around our rectangular prism, okay? So this formula, as long as you know the length, width, and height, you can find the surface area of a rectangular prism. For example, if we knew that the length was, let's say, the length is 3, and the width is 2, and the height is 4. Okay, if those are our dimensions, we can find the surface area of this prism by plugging in these values. So I'd have 2 times 3 times 2 plus 2 times 3 times 4 plus 2 times 2 times 4. 2 times 3 is 6 times 2 is 12. 2 times 3 is 6 times 4 is 24. 2 times 2 is 4 times 4 is 16. So if I add these together, I will find my surface area, and that is 30, 40, 52. Okay, so my surface area in this case is 52. So as long as you know the length, width, and height, you can find the surface area of a rectangular prism, right? Next, we have cylinders. Okay, and cylinders have this formula, which you'll notice involves pi because we have circles, right? We have circles on the top and bottom. So we're going to need pi to be involved in our formula, okay? Now, in order to find the surface area of this cylinder, we need to, first of all, find the area of the circles on the top and the bottom, right? And the area formula we have for circles is pi times the radius squared. Pi times radius squared. So if this is the center, and then that's the radius, if I know the radius, then I can find the area of the circle on the top and the circle on the bottom. That's why I have 2 times pi r squared, because I have a circle on the top and a circle on the bottom. I have 2 of them, okay? And then the rest of the surface area of the cylinder is, imagine you have a soup can, like Campbell's soup, and you want to peel off the label so that you just get down to the tin can, okay? If you were to unfold that soup can label, it would be a rectangle. Okay, it'd be a rectangle. And actually, the height here is the height of the rectangle, and then the base of the rectangle, or the length of it, is the distance around the circle, which is the circumference. So what we have here is essentially the circumference of the circle, 2 times pi times r, multiplied by the height, okay, because that is the area of the soup can label that we could wrap around our cylinder, okay? This is also called the lateral area. Okay, the lateral area. And you'll see in your book that lateral area is called LA, and sometimes they ask you to find the lateral area. That's what they're talking about. Okay, so in this case, all we need to find the surface area of a cylinder is just the radius, length, and the height of that cylinder. So if the radius is, let's say, 8 inches, and the height is, let's say, 11 inches, I can find the surface area. And because I'm dealing in area, the units will be squared, okay? So if we're using units, we will have that be squared. So for our purposes, again, we're going to use 3.14 instead of pi. So in this case, we'll have 2 times 3.14 times the radius, which is 8 squared. So 8 squared is 64 times 3.14 times 2. I end up with 401.92, okay? And then my lateral area is going to be 2 times 3.14 times 8 times 11. So if I do 2 times 3.14 times 8 times 11, I get 552.64. And you can check my math on that if you want. There it is right there for you. Okay. So if I add these together, then I'll have the surface area in inches squared of this cylinder. So I add those together and I get 954.56 inches squared. Okay. So that's the surface area of a cylinder. It's 2 pi r squared for the top and bottom circles, plus 2 pi rh for that soup can label that we would wrap around. Okay, now if we move on to pyramids and then cones, I'll move that down for just a second. If we move on to pyramids, here we're really trying to find the area of 4 triangles, okay, that are all around, pointing up, and then 1 rectangle on the bottom. Okay, so the rectangle on the bottom has dimensions length times width. So that's this part of the formula. This is the rectangle on the bottom. Okay, that's the bottom. And then for triangles, what we really need is we need to know the height of the triangle, right? Because as we can see for, let's say this first triangle that's facing us here, the base is L, right? The length of the base is L. And then the height of the triangle should really come down and hit that length at 90 degrees. Okay, so what it's going to do is it's going to come from the top of the pyramid and it's going to come down kind of at a slant like that, and it's going to hit at 90 degrees. Okay, it's going to hit the edge of the pyramid right there. Okay, so we call that the slant height. I call that S. Okay, S for slant height, slanted height down the side of the pyramid. Okay, like if you're sitting at the top of the pyramid and you take a toboggan ride down the pyramid, you're going down the slant height. Okay, so this slant height is the other thing that we need to find the area of this triangle. And remember, the area of this triangle is 1/2 times the base times the height, which in this case are L and S. Okay, so that's from chapter 5. 1/2 times base times height is that triangle. But remember, I have another one of these triangles on the back side. Okay, so I really get another one of these, and 1/2 times L times S plus another 1/2 times L times S really just makes 1, right? So I don't need the 1/2 anymore, and that's why this formula has L times S. Now notice here I have L times S1, because assuming the length and width are not the same, the slant heights coming down to the length and coming down to the width are not going to be the same either. So I call this one S1, and then S2 would be coming down this guy. Okay, so that right there, that would be S2, coming down the side instead of down the one that's facing me. So in order to find the area of these 2 triangles on the left and right hand side, we'll do the width, which is the base of these triangles, multiplied by that slant height. And again, because we have a 1/2 plus another 1/2, we get just 1. So we get this formula. Length times width plus length times the slant height down to the length plus the width times the slant height down to the length. Okay, so there's 3 things there that we need to know. Let's say, for example, that the length was 5 and the width was 3, and this slant height was 7, and this slant height was, let's say, 6. Okay? So now, given these 4 numbers, did I say 3? I meant 4 numbers. Given these 4 numbers, we can find the surface area. We just do 5 times 3 plus 5 times 7 plus 3 times 6, which would make 15, plus 35, plus 18, okay? And that would equal 30, 40, 50, 68. 68, and, let's say they're in feet, that's now feet squared because it's area, okay? So that formula is the surface area for a rectangular pyramid. If the bottom of the pyramid is a rectangle, you can use that formula, assuming that you know the relevant information, okay? Now, when we get to cones, let me just move some of the stuff down here. Whoopsies. That wasn't supposed to happen. Okay, we're going to move some stuff down. Okay, when we get to cones, it's a similar idea, okay, in terms of we need to know the area of the base, which in this case is now a circle. So notice I have the area of a circle here. This is, again, the bottom, which is now a circle, pi times radius squared. And the radius, would be from here over to here. That would be the radius. And then the the lateral area for this cone, like that paper that they wrap around your ice cream cones or your waffle cones, that surface area or that area is given by this formula, okay? Pi times radius times the slant height, okay? And the slant height is basically from the top down to the edge of the circle, okay? That is S. We call that S, okay? So our formula for the surface area of a cone is pi r squared for the circle on the bottom plus pi r s, where S is that slanted height down from the top to the edge of the circle, okay? So in this case, if we knew this time we only need two pieces. If we know the radius is, let's say 2, and we know the slant height is 3.5, we can find the surface area. Again, we'll use 3.14 for pi, 3.14 times, and then the radius squared, in this case 2 squared, that'd be 4, right? That's like timesing by 4. And then if we do 3.14 times the radius, which is 2, times the slant height, which is 3.5, okay, if I multiply all of those together, 3.14 times 2 squared, this is 12.56, plus 3.14 times 2 times 3.5 gives me 21.98. If I add those two together, I get 34.54. Okay, and that is the surface area for that cone. Pi r squared plus pi r s. All right, and then our final three-dimensional solid that we're going to talk about the surface area for is a sphere. Okay, and a sphere is difficult to think about in terms of covering. Okay, in the case of a sphere, the best way to think about it is like a baseball. Okay, so if you imagine in your mind a baseball, they sort of have two different pieces of covering that are sort of folded together and then stitched up, right? So the red stitches on a baseball, they come from two separate pieces of fabric that have been sewn together, okay? And those two separate pieces of fabric, they sort of look like this. They sort of look like dumbbells, okay, or like weights that you lift weights with, okay, and then things are folded up together, and then the other one sort of goes the other way, okay, something like this, and then it's folded all together and sewn up. Okay, now in the case of the surface area for a sphere, this is a decent way to think through why the surface area of a sphere, if you notice our formula here, is really just 4 circles. Okay, it's 4 circles. You know, and in the baseball, we can sort of see the 4 circles. Now, obviously, they're not perfect circles, and there's some extra stuff between them and whatever. But the surface area formula for a sphere is 4 times the formula for a circle. Okay, so it's 4 times pi r squared, and pi r squared, of course, is the area of a circle. Now, in this particular case, obviously there's only one piece of information that we need. A sphere is completely characterized by its radius, okay? And its radius could go here to the edge, it could go up here to the edge, it could go, you know, back that way to the edge. There's a lot of different places the radius of a sphere could go. But as long as we know the radius, let's say in this case it's 5, we can find the surface area by simply going 4 times 3.14 times 5 squared. And 5 squared is 25, right? So 4 times 3.14 times 5 squared gives us 314. Okay, and 314 then is the surface area of the sphere. So the sphere's formula is pretty easy. The thought process behind it, or where it comes from, is a lot more difficult. Okay, so we're just going to sort of approximate it, as I said, as 4 circles, and this is our formula based on the radius. So we now have formulas for the surface area of spheres, of cones, of rectangular pyramids, of cylinders, and of rectangular prisms. If you have any questions about any of those formulas, do please let me know. Reach out to me. I'd be happy to help or explain or walk you through some more examples. Otherwise, that's all I have for you right now, and we'll talk to you soon.